Hello, welcome. I am world famous chemist, chemistry teacher from India. My name is melaghumakra, and in the previous lecture we have discussed about suborbit subcell or sub energy level, and we see in L cell the P have two values. L has two values like L equal to 0 and L equal to 1, and L equal to 1 give the P or suborbit, and in this there are 6 electrons. Now again for M cell, L equals to 2, so it has when P L equals to 1, it gives P subcell, and when L equals to 2, it gives D subcell, and the value of electrons, maximum electrons in suborbit is D10, 10. So we have S2, S sub 2, P sub 6, D sub 10, and F sub 14 electrons are present in SPDF subcell. Means in S there will be 2 electrons, in P there will be 6 electrons, in D there will be 10 electrons, and in F there will be 14 electrons. Now we will discuss about the orbitals. The rapidly moving electron would occupy effectively the entire space around the nucleus, but at any given instant, the electrons would be found somewhere in a three-dimensional space best described by points of highest probability. The shape and size of this region in a space around the nucleus where the probability of finding an electron with certain energy is maximum is called an orbital. An electron can be anywhere within an orbital at any given time, although it tends to occupy certain portions of its orbital to a greater extent than other portions. Each subcell excepting S subcell is divided. P subcell contains 3 orbitals, px, py, and pz. D subcell contains 5 orbitals, dxy, dyz, dzx, and dx square minus dy square and dz square. And F subcell contains 7 orbitals. Now S orbital, electron charge cloud associated with an electron in an s orbital is spherically symmetrical. P orbital, there are 3 orbitals for each p subcell. If 3 perpendicular axes px, py, and pz are chosen, each p orbital is aligned along one or other of the axes. They are correspondingly termed px, py, and pz orbital. Hence, p orbitals have dumbbell shape. Now, d orbital. The shape of d orbital electrons clouds are more complex than either s or p orbitals. Every d subcell contains 5 d orbitals with the shapes. It has double dumbbell shapes. Now, quantum number. We have seen that Bohr's theory could not explain in the existence of fine structure in the H spectrum. The appearance of several lines in the H spectrum therefore indicates that only one quantum number n, as suggested by Bohr, is not sufficient for specifying the various lines. Then it was suggested by quantum mechanics that electrons are best described in terms of 4 quantum numbers, namely first principal quantum number represented by n, second azimuthal quantum number represented by L, third magnetic quantum number represented by m, and fourth a spin quantum number represented by S.